Good morning, everyone. My name is Fernandes. I'm from IDC, and I'll be your host this morning, and I'll also be one of the speakers. I'm joined today by Robin Kueper from Supermicro and Chris Carreiro from ParkPlace Technologies. Today's webinar is sponsored by the European Commission and the project ALLPROS, and we will be recording this session, and the session will be published soon after it is completed. Today's topic is the power infrastructure in the EU as it pertains to data center builds and operation. Additionally, just want to do a little bit of housekeeping. We will be presenting myself, then Robin, then Chris, and we will be taking your questions in the chat. And at the end, we'll have a little time for Q&A if anyone would like to participate, or you can just place your questions in the chat. We will reply to them live, or if not possible, we will send out an email with the answers afterwards. Okay, so I think we're ready to start. I'll start off with my presentation. So I'll start with my slides. Let me start sharing momentarily. Okay, so as I was saying, my name is Fernandes. I'm a senior research manager at IDC, and I work in the EMEA infrastructure and networking team. And I'm looking at, usually my work is looking at EMEA digital infrastructure strategies. Today, we'll be talking about the European power infrastructure, the current challenges that we're facing, and a few solutions on how we can address those. So as we know, the current power infrastructure is under a lot of pressure in the EU. In some regions, it's mainly due to geopolitics, and others, it has to do with an aging infrastructure from previous power sources that were being used, mostly fuel power sources, and the newer, more sustainable construction of power sources is not yet up to speed, at least producing the amount of power that would be required for the totality of power needs. In the specific case of data centers, in the last few years, power consumption has skyrocketed to a point where some member states have actually acted and created at least a moratorium on the construction of new sites. We see examples of this in this slide. This is the case of Ireland. They have at least paused the construction of new data centers because the power consumption of data centers was becoming too high for the power infrastructure in the country to cope with that. Now, this is not entirely new when it comes to the global market. Other countries have done the same outside of the EU, so it's not unheard of. But let's look at probably why this is happening more than how it is happening. For that, we take a look at the rise of AI and Gen AI. Leading this charge in power consumption are the GPUs that enable a lot of these new workloads that have come with the advent of AI. Robin will talk about this in a little more detail, but I just wanted you to note that the leading provider of GPUs, NVIDIA, is creating with every single generation, obviously, it creates more power-hungry systems. And they're increasing their revenue, which creates an exponential effect in terms of power consumption. This creates something that when it comes to building data centers, typically you would have a power structure of kilowatts per rack, and that in the last few years has increased very sharply to the point where we now have a single rack with over 100 kilowatts of power just for a single rack due to these new systems. Now, I'm going to go into the data part of IDC, that we have some data on the profile of some of these companies and that are using AI and some of the workloads that they're doing. And then Robin will talk more about the new systems that are being used for these workloads. And then Chris will talk more about how to operate and how to engage with these systems and how to make them work 24/7, 365 days a year. So basically, who is implementing AI and Gen AI workloads? A little bit of background on our research and this particular slide. We look at the market and we look at we use a digital maturity approach to companies. So we look at the companies and we see how their digital maturity is going on right now. And so we get around a quarter, around 25% of them, we consider them the leaders. They're usually the first adopters, the ones investing more in IT, investing in all the new things, all that is coming along in the market. Then we have around 50% that are the mainstream. And then we have around a quarter as well that we consider the followers. So these are companies that will embrace a technology when it is very mature in time, and that's when they actually invest in that particular technology. As expected, as no surprise to anyone, digital leaders are actually leading the charge when it comes to AI. 6 out of 10 companies at least are experimenting with AI and Gen AI workloads. But this is not without issues. So you can see that even the leaders, they are experimenting with AI, but only about half of those are actually using it extensively. Others are experimenting, but are not putting it into practice. And we see that even more obviously in the mainstream and the followers. So regarding the budget, where do we see the budget coming from these workloads? Well, to be honest, what happened was a lot of companies were taken a bit back by this boom in Gen AI. And what happened is a lot of them didn't have a specific budget for AI. So what we've been seeing is that in the last year and probably a little bit this year as well, they have been funneling their IT budget from other areas into the AI projects. Now, obviously, this can be a workaround in a specific situation, but there's going to be a sustainability issue moving forward, because this is not sustainable in the long run, right? We can't just ignore the other parts of the IT landscape just to put every single chip on Gen AI, and then have the other infrastructure just aging exponentially. Looking a little bit at the profile of the type of workload that they're applying and where they're applying. This is something we've seen over the years and in different perspectives, but EMEA and specifically the EU also follows this trend. There is a bigger appetite for private cloud, so private IT, whether it's in own data centers or third party, but it's a private access infrastructure across different workloads. There's a bigger appetite for that private cloud rather than public cloud or hyperscalers. That has to do with, it's a little bit different across the world, but in the EMEA, it has much to do with compliance, regulation, GDPR in the case of the EU, now DORA, a lot of different regulations and legislations, which frankly could or could not be used public cloud for this, but it's just frankly easier to do it in a private cloud, and therefore you're absolutely sure you're not going to have those sorts of issues with GDPR and other regulations. Now, here comes the problem with that. So what happens is that typically when you're trying to optimize a data center, obviously, as you can imagine, the sheer size of a hyperscale data center and the way they're built makes that their power consumption is much more efficient. Obviously, in the second class or second tier comes the co-location providers, which have also optimized to their extent the efficiency of the data centers. They can only reach so far because hyperscalers actually have specific hardware built either by them or for them, but the specificness of their hardware makes that it's optimized to their own infrastructure, so it can never be reached by other classes of companies. When it comes to the enterprise range, if I have my own data center, I'm probably using only a percentage of the time that particular infrastructure. So there's a bit of the infrastructure that is not being used, that is being wasted, basically. And that doesn't happen typically in co-location or a hyperscale because it's shared, and therefore it's always at 100%, right? Use or close to that. And in an enterprise, that doesn't happen. So we have a problem here where on one side you're preferring to use private cloud, but then you're not being as efficient as you could be. On top of that, when we asked what were the biggest challenges to build a Gen AI infrastructure, some of them have to do with cost, some of them have to do with data privacy, like we were mentioning. The problem with getting the GPUs, because at a certain point in time there was a problem with supply chain of GPUs because the companies basically couldn't build fast enough the GPUs required. However, there's 2 points that are very specific to private cloud, and that is those marked in red, highlighted in red, which is retrofitting a data center specifically for Gen AI. Now, this is obviously harder to do in a small data center, a private data center, rather than a co-location like ParkPlace Technologies or a hyperscaler. And also, the power, the cost, or ESG reasons that also make it very difficult to use their own data centers. So that's a push that they're getting, that companies are getting to run these Gen AI workloads. On top of that, we also asked what were the biggest impacts that AI or Gen AI was doing to the company's policy around efficiency and sustainability. Now, again, companies are trying to find ways to minimize the power costs, the power consumption, and not a lot of those are available in private cloud. So they, at least for a little bit, they're being pushed to public cloud or co-location or specialized deployment facilities outside of the scope of their own companies. So as a conclusion, I would like to say that we have this model. It's a 4-level approach, like an onion model, as to what we should do to better utilize our resources in terms of power. And given that all that we are seeing, there's a lot of things that we can do, obviously. We can have a more efficient and modern infrastructure. That's one point. We can use automation, AI ops, to optimize the use, not have that waste that I was talking about, have a more adjusted capability to the infrastructure that I have. We can do things around energy supply, so remove any energy supplies that are not very sustainable or that are high carbon energy, and change that to renewable or low carbon energy supplies. Now, all of those things are going to have some effects on the amount of power that we're using, but it's not going to be life-changing. I think the big part here is the way that we cool, that we do the cooling of the data center, the power and cooling, how we can change that dramatically, from more of a, instead of an evolution standpoint, more of a revolution. And that fits in well with what Robin will speak afterwards. So I'll let him, I won't steal his thunder, and I'll let him present his slides. Again, this is my last slide. Here are my information if you'd like to reach out. And now I'll move on to Robin. And Robin, maybe you can share on your side, and I'll stop sharing.
Okay, thank you, Luis. So let me get this one started. And hopefully you can all see the slides on this one. That would be fantastic. So good morning, everybody, and thanks, Luis, for the introduction on this one. So my name is Robin Kueper, working for Supermicro and part of the product and solution group in EMEA. And as part of that capacity, my role sits basically in being an ambassador to the company. So talking to our customers, talking about our portfolio, talking about our solutions. And with that comes also overcoming some of the pain points that those customers have. And in particularly on power seems to be a hot topic, given the situation that we see in the market, all fueled around AI. So, and as an example, you know, if I talk to a customer and we talk about the customer challenges that they highlight or that we know, in a very traditional commercial enterprise business, these might be 8 of them that are top of the list. So, of course, these companies want to grow and they want to talk about innovation and how IT can help them. And that basically brings it back to a basic point, because we always say, you know, IT should be not of your concern because you need to focus on your core business. But the reality is that IT is basically their core business now, or at least it's a part of their core business. It's so weaved in whatever that commercial company is doing that IT is going to make it or break it moving forward. So if they talk about growth, they automatically think about what can IT do? They talk about productivity from an IT perspective. They talk about, hey, if I go to deploy new solutions from an infrastructure point of view, do I still have the freedom to choose? Because it's a very dynamic market with technologies and vendors coming in and out. So they don't want to get locked in. They want to look at the agility of the organization, their insights. They're sitting on tons of data, avoiding risk and being different to the competition. But the energy one has come up more and more over the last couple of years. So there is an understanding that, you know, energy cannot be taken for granted anymore. And I wouldn't say that pain is that bad that everybody takes it seriously. Talking to somebody yesterday basically said, you know, yeah, they all want to do AI, but they have no clue what kind of power consumption comes with it. And they all think it's fine. And until they start deploying it or until they start talking to their energy company and come to realization, yeah, energy is not unlimited at the moment. And depends on where you are in the country. If you're in Iceland, you might be in a much better position. But if you're in Western Europe, you need to have a negotiation with your energy company to bring it to the right levels. So the efficiencies on energy are a key pain point for most of the customers, and they're in there. Now, then I hear other people say, yeah, but it's not all about commercial companies and enterprises. There might also be governments or institutes, and how are they looking at it? And I'm not sure if everybody's aware of, but currently in the EU, there is an EU factories kind of initiative going on, fueled by the European Commission, and it's about shaping Europe's digital future. It's a 1.5 billion euro investment by the EU, and where it comes down to is 7 locations has been nominated to build an AI factory, and through that AI factory, they need to provide a service to small, medium business, skills up, other kind of companies that don't have a direct access themselves to AI. And the EU wants to provide a service to them. Now, if you look at these 7 locations, you might recognize some of them, but they're all coming from the HPC area by large. Yeah, so they are used to manage clustered solutions. They know what a rack is, they know what a server is, and they know what it is to take a data center to the next level. However, still there are challenges with them. One hand is more operational. How do you shift from a more research institute serving universities and research institute to a more service provider and provide a service to businesses of all sizes, or maybe some customers that they don't deal with today. But even with them, if you talk about their challenges, and they typically don't call it pain points, they call it more challenges. Their top 5 infrastructure challenges are largely comparable to what we see on the consumer side, or sorry, on the commercial side. So they talk about scalability, they talk about data, they talk about quality and value-added services. But clearly, and this isn't a random order, but one of those 5 is about energy efficiency and sustainability, especially as it is EU funded money. And it comes with a lot of rules and regulations on it from sustainability point of view. So even more than some other customers, they pay attention to, you know, what are the energy efficiency levels and how do you get there and how can we work with you on all these kind of solutions. Now, if we go back to the topic of this one, conundrum, maybe it's a new word for many of them, but what's the definition of a conundrum? And basically, it's a complicated, confusing, difficult problem, which seems to be an impossible solution to crack. And I think if I would flash that up at many customers from our side, they will probably focus on the word problem, because that's the red flag. Say, something is going wrong here, we need to pay attention to. I would rather focus on seemingly impossible, because it doesn't say it's totally impossible. You can get there. It's a question from how do we get there? And are there new technologies and are there new solutions on the horizon, or maybe even here today, who can solve those challenges for the customers? Now, I've been hanging around here in this industry for a while, and I've seen many trends and hypes coming by, and I just mapped them out to showcase something to you. On one hand, I think we're all familiar with hypes. They come and they go. I mapped them out over here. In the old days, we started talking about clustering. It was really a big thing. .com came along, virtualization, and we're now pretty much in the machine learning and artificial intelligence. And you know, whichever I go, it's always about AI. If I switch on the TV, it's about AI. If I go to a birthday party of somebody in my family, it's all about AI. So clearly an hype. And I don't think any marketing organization can beat a good hype on this one. So it fuels a discussion. I'm personally more interested in the trend on this one. Where does these hypes that come and go bring us from the long-term perspective? And that's a trend on where we use that technology and prosper our daily life, you know, working differently, working more efficiently, and all these kind of things. So the thing on this one is where we started and where we are today, they basically, all these hyper trends are power hungry, but they're also giving us much more performance than in the old days. You might have heard about the joke about the power that a mobile phone holds is probably X time of the computer that was fueling Apollo 11 that brought the first people onto the moon. You know, the capacity and the power that sits in the performance areas of those CPUs are many, many more times than in the old days. So with that, you can imagine, and Lewis already showed a graph on it, how powerful a GPU is nowadays to run artificial intelligence solution. It's crazy. It's unbelievable for a lot of people how much power goes in there. The challenge is maybe not performance, but performance has always been increasing. The industry has done a really great job in bringing more performance to people's fingertips. But with performance comes thermal design power. And with thermal design power comes energy consumption. So one leads to the other. And the whole name of the game basically is about, can we balance this out and what we can call an efficiency? And we come to the conclusions that are essential. And somebody in the semiconductor industry who brings a new product to market will probably double down on their efficiencies to showcase where the performance goes hand in hand with TDPs and energy consumptions, because at the end, we need to keep those wheels turning. If not, the whole system will crack. You know, it all integrated to each other. So if I go back to these hypes and trends kind of overview, the ones that were more or less highlighted as a energy consumption or a power consumption threat to the progression, it started with clustering when we started to build bigger computers than ever before. When cloud computing came along, we saw the same. Blockchain was definitely a big one. That's where everybody got scared about the power and everything. And now we are in AI, same story. So the green ones are very power demanding. But we do have a very strong industry track record on this one, what you could call out digging ourselves out of a hole as an expression, because if you look at the PUEs and the improvements, we basically started at a 3.0 roughly, and we're now at a 1.05 in average. So as an industry, we created a challenge, but we also solved it. And I think that's the ongoing kind of thingy that we constantly see, and where people are basically put a lot of trust in us to keep that going. So GPUs versus CPUs, you know, what is fueling this current performance? And it's clearly on the GPU. Lewis already highlighted it to a large extent. GPUs are taking over from a performance perspective from the CPU, which is not a bad thing. It's just a evolution of the semiconductor industry with new use cases on this one. Now, a lot of people say Moore's law might have come to an end, and they might be right from a transistor density point of view, but from a performance point of view, it keeps going. And we do see a shift from workloads driven by CPUs now into the GPU arena. And with that, as we said, it comes with a consequence about heat dissipation. Now, GPUs are hot, and they're hot in three ways. They're hot from a stock market perspective, for those who want to invest their money. They're hot from a technology point of view. Everybody wants to have them, the latest and the greatest, but they're also literally hot from a TDP perspective. These GPUs nowadays become very, very warm, and we need to find a solution to cool them down. Otherwise, that whole mechanism that I showed earlier comes to an end. We're pretty much now into the 1,000 to 1,500 TDP watts. With new announced solutions, we're now raising the bar to over 2,500. And I think this trend line will continue. So this doesn't come to an end as far as we can see it right now. So if we take it from a rack perspective, just a simple example, we'll not spend too much time on it. But if we go way back in time, a couple of decades ago, we were talking about standalone kind of servers. And if you would populate a rack, you would have different price points, of course, but you might need a 3 to 5 kilowatts kind of power consumption per rack, which was doable by that end. When we started to talk about clustering, especially the HPC clusters, which went really crazy by everybody wanted to be the top 500 from a cluster performance perspective, prices went up and the focus moved from CPU to cores, but also the energy consumption went up into the 10 to 40 kilowatts. And now with AI, and we're talking about rack scale solutions, so basically a rack has become the new computer nowadays. Prices has gone through the roof, over $1 million kind of investments. The focus is on GPUs, but the power is about 140 Ks and even higher. And I think Lewis was mentioning 100K, which would be a conservative number, not a wrong number, but 140 would be the number that most people would look at nowadays. So if we put a trend line here from a rack power consumption perspective, most of the opportunities we work on sit within that 100 to 200 kilowatt envelope, which is all doable. Not a major concern to many customers, but yes, you need to be ready for it. But we now see customers coming in with a request for solutions that are going into the 480, so almost 500 kilowatt kind of solutions. And we're working on those deployments. Early days, a few only, but it's starting to surface, and it builds to a trend that this is not the end. And when we look at roadmaps that were given by our industry alliances, but also if we look at the total ecosystem, if we go to exhibitions and talk to anybody who has an interest in IT and is building solutions or capabilities, we're getting insights that it might go up to the 800 kilowatts, so close to a 1 megawatt kind of rack deployments, which is really going to cause a challenge for us as an industry. Now, Three types of customers that we see who are dealing with the efficiencies. We got savers, optimizers, and growers. The savers using consolidation, so they're going to use the latest and greatest technology for doing the same for less. We see those who want to do an optimization, so they consolidate first and they fill up the space from a power perspective or money perspective to get to the next level. And then you have the people, the growers that do more for more. Basically, for them, power doesn't seem to be a problem. They want to go for the extreme, and they're building the latest and greatest. Question is, will PUE help them getting there? Even if you're a consolidator, an optimizer, or enablement customer, can there be a technology out there that helps you? And basically, to us as Supermicro, we believe that liquid cooling is the only viable solution for the long run. So a couple of years ago, that market was roughly about a 2 billion size. It's predicted to be a $12 billion market in 2032, which I think is a conservative number. I think it will be higher. But basically what it says is power efficiency will likely go hand in hand with liquid cooling efficiency. So talking about liquid cooling efficiency is all about how much of that heat can you cover by liquid cooling into a system. And we're now at roughly a 90% kind of threshold where we can remove 90% of the heat by cooling it down through liquid cooling out of the system. We started at 50, 60% rates. We're now at a 90% rate. So huge kind of steps forward from a liquid cooling perspective. And you see an example over here based on NVIDIA's a B200 GPU, how you can achieve or how we can achieve a 90% liquid cooling platform. But where I basically want to go through is three options from a liquid cooling perspective. You can either do direct-to-chip cooling, you can do rear door heat exchangers, or you do the immersion cooling. Three variants out of in the market. Whatever the customer prefers, whatever fits the customer best. But this is then a potential solution for overcoming your pain point and driving the efficiencies to the next level. But if we map them out, if we compare them, and you take all the elements, all the criteria that most customers take in, there's basically one winner from all of them. So leaving air cooling for what it is, because we already concluded that might not be viable. But from the three left, direct-to-chip, rear door, and the immersion cooling, it seems that direct-to-chip hits most buckets with a green or a low number where it's applicable. So for us at Supermicro, direct-to-chip cooling is truly the big bet. That's where we believe next generation of technology will be equipped with to cool it down and to get those efficiency level at the rate where they have to be or where they need to be for the future. And giving an example on what a good PUE with direct liquid cooling can do compared to air cooling can be an 80 million kind of saving over 5 years in this example, because we brought the PUE from a 1.5 to a 1.1 in this example. And even if you do a partial PUE, so basically you isolated some of the equipments, in this case the server, you can bring it almost to a 1 point of view, giving you those savings. And this ties back to the first two slides in my deck about customers. How do you overcome the pain point and at the same time save money on it? Question will be, can we go lower than 1 on this one? Can we go to a sub 1 PUE? It's possible. If you are having an ability to bring the heat rejection factor down, you can go under 1, and you can basically only do that now by connecting your data center to public heating networking and bring warmth to the city or anything like that one. But the industry will move forward to bring the PUE numbers down. But this is currently where we are and what we see as the stretching ourselves. Now, can we clearly say we've overcome the conundrum? To a certain extent, yes. So we know what the challenges are. Yes, there are limitations on the energy level, but there is technology out there with liquid cooling. And although this is not in Europe, and I know there's a little bit of an AI war going on between the regions across the world, Middle East versus Asia versus US versus Europe, but this is an example, the X1, also called Colossus or Grok supercomputer, which Supermicro powered by having 100,000 NVIDIA H100 GPUs there, which basically gives them 64 GPUs per rack. These are liquid-cooled servers and build a supercluster. So initially, there were a couple of limitations here, but you see the technologies allows us to buy these supercomputers today. So I think we got some proof in here. So the proof is in the pudding, of course, that you can still scale and grow your AI demand by having the technologies there. You just need to pick the right ones. So with that, Lewis, do I give it back to you, or Chris, do you want to step in immediately?
Mhm.
Yeah,
I can.
I think we can move directly to Chris. Thank you for that, Robin. Chris, the floor is yours. I'll just mute myself.
Perfect. Well, thanks, Lewis, and thanks, Robin, thanks for the introduction here. Ultimately, just a quick little blurb about myself. So I'm the CTO for ParkPlace. We're a data center services company. We support 181 countries globally, 22,000, I believe 22,500 customers globally. So we're in pretty much every data center everywhere from a field perspective. We have field engineers, backline, full parts delivery systems, all for essentially vendor agnostic. So we work with all different OEMs and server, switch, and network, but anything in the data center. And ultimately, we ran into the same problem. We wanted to get our field up to speed and make sure that we're current. And I realized that we're ultimately in this conundrum. It's not just on the GPU; it's actually on the CPU. But ultimately, like this ASHRAE slide here shows that anything over 200 watts. So now you have a 1U server, 2U server. You start bleeding into this space where you need liquid cooling. So our CPUs, traditionally back when we had 4 kilowatts per rack, was a big difference. We didn't have to worry about removing all that heat from such a small surface area. So essentially, now that we're creeping in past the 300 into the 400, that's where you actually can't remove the heat with air. So ultimately, the industry is moving towards requiring something other than air to remove it. So we started down this journey a little over 3 years ago. There are the three types. There's a couple others. In each category. You have single, two-phase for immersion. You have single and two-phase for direct-to-chip, and you have the rear door. Not all of them make sense in certain variations. I think clearly the direct-to-chip is going to be the outperform all the others due to the clusters and the need that we have within AI for direct-to-chip. But ultimately, they work very similar to the same. You have a heat exchanger within inside of a facility that connects to a outside evaporative cooling tower, a chiller, some type of source that changes the inlet temperature from the outlet temperature, and then that connects to some kind of CDU or a coolant distribution unit, and then that hits the actual cold plates. So the first big thing that this is a disruptor in the industry is traditionally IT folks, data center operators, they didn't care about water. They didn't want water in the data center. They're hydrophobic. They wouldn't have water plummets inside of the building, or maybe they did, but it was outside of the data hall. But now it's a requirement, and it's a requirement in some data centers, not only to bring it to the row, but some of them right up to the cabinet. In this slide here, you can see the rear door heat exchanger, which actually makes a lot of sense for storage devices, potentially for switches. It's basically solving the problem of, instead of cooling the entire facility, you're just cooling that individual rack. So now, if you deploy that high density, if you're in that 100 kW, if you're in that even over 40, if you're in the 50 to 80 kilowatt, you're going to need some type of liquid cooling. The rear door does make a lot of sense when it comes to the storage devices, but it's very complicated to get deployed. It's very expensive. Now each cabinet needs to be fitted with it. We're running into challenges now with these AI machines that are much larger and wider inside of some of these cabinets, some of the standard cabinets that you're used to. So there's a lot of things that are changing together. And ultimately, what ParkPlace does is we're a services entity. We have to support all of these different complex systems or complicated things. One of the other options is immersion cooling. Immersion cooling has probably the best PUE, but it's probably the most complicated and it's the messiest. 1.03 is the best PUE that I've seen from an immersion tank, and you can get rack densities close to 400 kilowatts per rack for 42 U's. It makes a lot of sense for a lot of edge deployments, which is good because it actually blocks some of the dust and contaminants from the actual system. But ultimately, the bulk of the industry, it's probably going to be over 3/4 of the industry is going to be direct to chip, or at least what I think. The direct to chip system itself is a little complicated. There isn't much standardization between different OEMs. So if you're a sole Supermicro shop or a Dell shop or somebody, if you have one product, they each have their own solution, and then it connects into the facility water loop. So it does get a little complicated, and we try to help alleviate some of these challenges and try to drive an easy platform from that serviceability piece. Granted, direct to chip's probably the easiest to actually support. The system itself isn't much more than unhooking the water loops from the back of the chassis, but you actually have to remove the system from within the cabinet, very similar to a traditional cabinet, as compared to immersion, where you're lifting a server out of oil, usually with a crane, and those types of challenges do make it a little more difficult for a lot of the self-service. So we do help. We learn the products. ParkPlace learns the products. We roll out this training out to the field to support some of these pieces of equipment. This is a good slide here. This kind of explains some of the benefits. You look at air cooling to the left, DTC single and two phase, and then you have immersion and immersion cooling. So some of these immersion is definitely very disruptive, but you can see DTC single phase is what most of the server manufacturers are choosing out in the field. So some of the key benefits to direct to chip, you have that improved energy efficiency, and the reason that we're moving to liquid is 50 to 1,000 times more efficient than air for removing that heat. You're wasting, outside of just the heat that's within the server, you have air conditioning equipment within the facility, you have raised floor, potentially rackings, hot cold aisles. You have all of these things, that improvements that have been made over the past 30 years in the industry, and liquid cooling really solves quite a bit of this challenge. You have 30 to 40% of that power you can actually put back into the data center, so you can sustain and get those higher CPU workloads. The reduced energy translates to smaller carbon footprint, so that those carbon neutral goals were actually in Robin's previous example of selling it back to a municipality and actually having a heat source for either heating homes or water back within the grid. But one of the main reasons that we see liquid cooling really blowing up now, and this technology has been around for quite a while, is that server density. Everyone is in this race for getting servers and clusters closer together in this higher than 100 kilowatt, 140, 150 kW per rack. It's all about that server density. So some of the other or alternate or secondary benefits too for some of liquid cooling is that enhanced performance and reliability. Heat is one of the largest factors in server failures, and removing heat from the source keeps most of the heat out of the chassis, and therefore you have less failures from that. You do have the additional challenge of water running very close to the inside of it, so that installation, the service needs to be very specific. It's not as easy as an air server, but that enhanced reliability definitely, adding more uptime to that server does make a big difference. So, and then obviously scalability and then the simplicity of installation are two very key points to direct the chip liquid cooling. I'm just going to flash this slide here. This is basically the different things, as I mentioned, what ParkPlace does do from procurement. The conversion is one component. So we do service actually from a great partner, Supermicro. We do some of the installations out in the field for them, but we do other conversions, installations, and actually maintenance on this equipment. So service is definitely key, in having good service in this liquid cooling journey is very important while we're in this transition phase from air to liquid. So I'm going to end there. I'm not sure if we had any questions at all.
Not at this moment, Chris. I'm just gonna while we wait, if someone wants to ask questions, I'm actually going to open a slide with a few recommendations, very related to what the three of us were talking here. Sec, just to share actually. Okay, here we go. So basically, these are the recommendations that we would suggest. Either you're building a new data center, or if you're thinking about refitting your existing data center, like Chris just said, partnerships with experts are key, because there's a lot that can go wrong, obviously. And we know by experience that Murphy's always right, so you don't want to mess with that. But I did find very interesting what you said, Chris, about liquid cooling, how the direct-to-chip, although deployment can be a bit of a hassle in the beginning, then it becomes actually a blessing in disguise in the long run, whether it's for serviceability, because immersion and other technologies make it really, really hard to do the serviceability of the systems, but also the fact that because the systems are cooled and not running at high temperature, there's less impact in the amount of issues and components breaking down over time. So that will probably even extend the life cycle of the components and the systems. So I found that really interesting. I don't see any questions either. Oh, there's. Okay, so we have one of the attendees is asking in the chat now, what are the investment differences between air-cooled and liquid-cooled for customers, not only from a hardware point of view, but also from a skill point of view? So I would probably divide that question into two. So from Robin, I would probably ask him, what's the difference in terms of infrastructure investment, in terms of difference between air-cooled and liquid-cooled? But then also to Chris, what the difference in investment in data center facilities, but also the part about the skills. Because correct me if I'm wrong, Robin, but from a skills point of view, in terms of managing the system, it's exactly the same.
Yeah.
Like there's not a different tool or a different set of tools to manage your server that is liquid cooled or air cooled. You don't even have that visibility from the administration side, but there is from Chris's side, from the data center operation side. But please do intervene.
Yeah, so to a certain extent, you're right. So a lovely question for Mike. So thank you for that one. So from an investment point of view, versus air-cooled, yeah, you're talking about a little bit of a premium investment. So, you know, the liquid-cooled solutions do come a little bit more expensive than the traditional air-cooled. Question is, do you have an alternative? The good news on this one is, if you look at the ROI, you can earn it back very easily. So, you know, you see some marketing slogans out there, liquid cooled comes for free, in the sense that if you benchmark it against air cooling, you can have some savings and you earn it back and all these kind of things. So from an investment point of view, yes, you need to pre-invest, but you're earning it back. And the example that I showed clearly articulates that one. So that's one. On the other one, where Chris is probably a little bit more of an expert, what we do see from Supermicro is where, from a data center point of view, traditionally, the IT administrators were maintaining the compute and the storage and the network of it, and the facility guys were doing all the plumbing work, the floor, and the doors. That starts to be merging now, and it becomes a more teamwork than ever before, because with liquid cooled, we're basically directly now connecting the facilities into the server equipment. So that's a different aspect. And although the facility teams probably work more on the liquid cooling side of the house than on the IT admin one, they have to talk to each other. But where they clearly integrate from a Supermicro point of view at this point in time is the system management. So at Supermicro, we do the whole ecosystem, the whole stack. So we do the Supermicro water towers, we do the CDUs, we do the cold plates and everything. And I love Chris' example about saying, you know, where should you be more feared about the heat or the water or the fluid? And I think we have to start changing people's mindset. You know, I wouldn't be that scary about fluid anymore. I would be scared about the heat in the future. But from a system management point of view, our system management solution, so Cloud Composer, does do the full integration of the liquid cooled solution. So we do measure the pressure in the system, potential leakage, and all these kind of things. So I think the worlds start to come together. System management done for us, but an integration on the floor, that's probably more where Chris has a better view on.
Mm-hmm. Yeah, definitely. Thanks, Robin. And I did kind of want to touch on the first half of that question about the difference between air and liquid. You got to think of this holistically. If you're going to be deploying, let's say it's an air-based AI system, let's say it's an 8 GPU server chassis inside of a cabinet, you're going to get low rack density. So you're going to have to spread these servers across multiple cabinets. And you might have to make an investment on air conditioning. So if your data center can't sustain, you're going to probably create hotspots in that data center. So you have to look at the cost savings there. Instead of spending money on more air conditioning, you're spending money on the CDU and then the manifold and all the components, potentially a water tower, all of those other things. And then you'll make the rest back as now your PUE is lower. You're going to save money on power, uptime, and all those other things. But you definitely have to look at things holistically, like as if you could take air, drop it in. It's not an apples to apples comparison. You have to kind of step back, take a bigger picture view. And that would make things easier to get funding for deployment for some of these big systems. And then the second piece of that, it's very interesting. In the field, I've only been working with mostly IT folks forever, in my entire career, working with server people, storage, network people. Now, the people that are calling in some of these conversations that we're starting with, big companies, are the actual HVAC or the engineers from the facility. And the reason they're calling in is because they're faced with the problem. And the problem is our IT guys, they drop this heavy 15,000 watt server in my data center and it's creating hotspots. I don't know what to do. They're scared of water inside of the data center. So it is a learning element to it that they have to understand, properly cared for. Things that liquid cooling's been around for a while. It might have had negative connotation with that person in the past. So they're a lot more open to it now because they're trying to solve this heat problem. They're trying to drive these systems and essentially working hand in hand with the IT folks, when traditionally, or at least the last 30 years in data centers, it was basically, I need this much rack space, this much power, and 5 network drops for a rack. And now it's much different. I need an inlet water temperature of this, and I need this much floor space. And in some cases now, there's a weight restriction for these systems are very heavy and they're sitting on just a few small square feet. You have almost an 8 GPU system. I think the average weight is close to 100 kilograms, which is very heavy. 5 of those inside of a system is extremely heavy. Thanks, Mike. Appreciate that.
Okay, thank you, Mike. I don't see any other questions. As always, as this is going to get published, then you can reach out to us either directly or through the ALLPROS team. Feel free to ask any questions that you might remember later on. And I'll probably close the session here since there's no other questions. Thank you so much to Robin and Chris and everyone that attended live. And you can see the repeat when it gets published in the ALLPROS website. Thank you so much for everything.